Stanford University.
All right, well, welcome to Lecture 5 then of CS 193P. This is fall of 2017. So I'm going to take just a few minutes at the beginning here to go over just a couple more little Swift things. These are actually in your reading assignment for this week, so I'm really just kind of emphasizing these things. Then we're going to dive into our main topic today, which is views, okay, drawing, how you do custom drawing in iOS. And I'm going to start with a huge demo. The only thing I'm going to probably be able to do today is the model of our MVC. But that's going to allow me to show you an example of enum, which we didn't get to work into concentration, so you only theoretically know enum, and we'll be able to actually do enum. All right, so let's do these little minor things. Okay, one of them is error handling in Swift. Now, a lot of times you'll have an error, and it will be something that kind of could be expected or anticipated. You know, you do something over the network, and there might be a network timeout. That's kind of a normal error. If you had that kind of error, you likely would have an argument to the function that goes and does that network call. Maybe it's even a closure that calls you back and said, oh, I found this somewhat expected error. But sometimes you have errors that you don't expect, or that are kind of rare and really disrupt the usage of a method or whatever. And in that kind of error, instead of having to have one of your arguments be an error handler or returning an error or something like that, you can do something that's called throwing an error. Okay? Now, in other languages, you might think of this as like raising exceptions or something like that. It's a little simpler and more elegantly designed in Swift. It's as simple as this. A method that could get an error, okay, a significant error that would disrupt what it's doing, can decide that it throws errors. And you see these methods very clearly because when they're declared, they'll have the word throws at the end. So this function save throws. Okay, if it gets an error, it throws this error. Now, when it throws an error at you, you need to catch it, okay? And you catch this error, and then you can look at it and decide what to do. So how do you catch an error that has thrown? Well, you do that by putting this doCatch construct around your call to the method that might throw, and you say try in front of the call. So you're going to try this method, but it might throw. Okay? But since you've put it inside this doCatch thing, like that you see up there, you're going to catch that error. Okay? So it's as simple as that. So any method that throws has to be called with try. Okay? You have to let Swift know, I understand that this can throw, and so I'm trying it. But it doesn't necessarily have to be caught, and I'll show you in a second how to do it without catching. If you do want to catch, then you do this doCatch, and in the catch you notice there's the green let error. Okay? That little error thing, it's just a local variable, that's the thing that gets thrown at you, okay, when it throws an error. And it's going to be something that implements the protocol error. Okay, but there's actually nothing in that protocol. It just identifies, it's just typing this thing as error. Now, in iOS, when errors get thrown at you, they're almost always going to be NS errors. So an NS error is just a class. It implements the error protocol, which is to say, it does nothing in particular. But NS error has a lot of nice methods and vars in it, like the error code, even a localized description of the error that you could present to a user, for example. So the way this goes is if you had a function save that throws, you're going to go look in its documentation and see what kind of NS error stuff it can throw. And it'll throw certain errors like save. The save, maybe it's for saving into a database and the disk is full, so the database couldn't save. So maybe there's an error code for disk full or whatever. So this is what you do if you want to catch a thrown error and kind of handle it. Look at it, see what it is, decide what to do. But you can just say try exclamation point, and what that means is try this, and if it throws, crash my app. Okay? Now, you would only do this if you were 100% certain that that thing could not throw in the circumstance that you're doing, which is extremely rare. So we rarely do try exclamation point. But a better one, if you don't care about the error, is try question mark. So try question mark means, please try this, and if it throws, don't crash, but just ignore the fact that it threw. Okay, so this is kind of like try and ignore. Now the interesting thing is, you might be calling a function that returns a value, okay, and that can throw. So here I've got my error-prone function that returns an int, okay, and so what if I want to try it with try question mark? Well, if it succeeds, I need that int back, but if it fails, I can't get the int back. Okay? So what happens when you do try question mark? It changes the return value, essentially, of the function to be an optional version of that value. So if you have an error-prone function that returns an int, and you try question mark it, and you let it equal something, let x equal that, this x now becomes an optional int. Because if it throws, it's going to give you nil. If it doesn't throw, you'll get the normal x value that error-prone function that returns an int returns. Okay? So that's error handling. There's not a lot of methods that throw in iOS. They're in there occasionally. You might have a typical app, maybe have 3 or 4 of them somewhere. They're fairly rare, but you got to know how to handle them. So these are the ways you handle them. All right, I want to circle back now to any. Okay, this type any that we saw with NS attributed string dictionaries. There's also another one called anyobject, which is exactly the same as any. It's just for classes only. Anyobject is the any of classes only. And I told you that any means you don't know what type it is. It could be any type. Okay, and we also know that that's not very Swiftian because Swift is strongly typed. Okay, so any and anyobject are in there for compatibility with Objective-C. Objective-C had a very important type called ID, which was essentially any, and it was built into all the APIs. So when Swift came along and tried to be strongly typed, it had to have this one concession. Okay, so we don't use, as I said, any in our own code. It's for backwards compatibility. So variables of type any can hold any type. Okay, structs, enums, classes, anything. Okay, and the problem though is you can't send any messages to something of type any because you don't, in your code, know what it is, okay? Now Swift under the covers might know what it is, but since you've typed it any, it's assuming you don't want to send any messages to it, that you don't know what it is. So how do we deal with that case in Swift where we've got a strongly typed language, we can't send a message to any? Well, we got to convert it, okay? Now, let's talk about where you're going to see it. You already saw it in NS attributed string case, right? Where we have that dictionary. Another place you'll see it is arguments to methods. Okay, so here's a method called prepare for segue. It's a UI view controller method, right? You know what a UI view controller is? We made one for concentration. And I talked about when we do MVCs and we have multiple MVCs and they own a whole screen. Well, we sometimes transition from one MVC together to another. And this prepare for segue, a segue is a transition from one MVC to the other. This gets called in a view controller when that transition happens. Well, one of the arguments to it there at the end is sender of type any, question mark, okay, an optional any. And that's basically what button caused this MVC transfer to a new MVC. So it could well be a button that sender is. But it can also happen if you click on a row in a table view. So that's not a button, that's a table view cell, okay? Or it could happen from something else. It could even happen by code, in which case this is nil. So that's why you need any right there, because you're not sure whether it was a button or a table view cell or something else that caused this thing to happen. So you'll see it as arguments occasionally, very rarely, to a function like this, where you can kind of pass anything in there. But how are we going to use this any stuff? Okay, let's say a button was passed there, a table view. How do I know what it is and talk to it and all that when it's this any thing? Okay, so, oh, yes, before I show you how to do it, of course, don't use any in this course, except for to do backwards compatible call APIs. Okay, you don't have your own data structures, would not be use any. Okay, some people try to use any when they basically don't know how to design a data structure, and they're like, well, I'll just make this an array of any, and I'll just start throwing random things in there. No, we don't do that. Okay, that's not Swift. All right, so now how do I use any? Okay, I have to convert it to a type that I do know. Since I can't send any messages or vars, I have to convert it. And we convert it with a special keyword in Swift called as. Okay, as question mark. And what as does is it just tries to convert that any to the type you specify, and if it can't, it returns nil. That's why it's as question mark, okay? And it's as simple as that. So here's an example. It's best learned by example here. Let's say I have a var called unknown, which is of type any. So I don't know what's in it. It could be anything in there. And I think that thing in unknown might be of type my type. I'm not sure, but I think it might be my type. So I'm going to say if I can let foo, which is a new variable, equal unknown as my type, then inside there I can send messages to foo that my type understands, right? So I've just converted unknown into a new variable of type my type, if possible, by using as. And you can see this is nice. It reads like English. If I can let foo equal unknown as my type, then I'm going to use it as my type. Okay? So that's it. It's very simple. That's how we access any. And if it wasn't, if unknown was of some other type and couldn't be interpreted as my type, then the curly braces, that stuff doesn't happen. You could even say else, and something else would happen. That would be fine too. Okay? Now this casting of as was not just for any. We can also cast other things. Why else would we ever want to cast? Well, one classic one to cast is to cast from a variable type to one of its subclasses. Okay? So let's look at an example of that. So here I have a variable, VC. Very importantly, it's of type UI view controller. In other words, the iOS class, UI view controller. That's the type of VC. Now I'm setting it equal to creating a concentration view controller, which is a subclass, let's say, of UI view controller. Okay? Now the type VC, even though I assign to it a concentration view controller, that type is still UI view controller, not concentration view controller. That's not its type. Its type is UI view controller. But this is a legal statement because, of course, a concentration view controller inherits from UI view controller and thus is a UI view controller. Now, if I wanted to send flip card, let's say that was a method in concentration view controller, to VC, I could not do that. It would not even compile. Why? Because VC is of type UI view controller, and the class UI view controller doesn't have flip card. Concentration view controller has it, but not UI view controller. Okay? So people get confused about this. It's kind of like back when we were talking about the protocols and I had things to move and it was of type movable and I had a car in there and I wanted to send it change oil and people were like, why not? Well, because the variable was typed to be a movable and movables didn't know how to change oil. Cars do. This is the same kind of thing here, exactly the same thing, just with inheritance instead of protocols. So what if I did want to send flip card to VC? How would I do it? Well, I can cast with any in the exact same way. I can say if I let some new variable called CVC, concentration view controller, equal the VC as a concentration view controller, now CVC is a concentration view controller, I can send it flip card. Okay? So same way I did with any, I'm checking to see if it's possible for this var to be converted, in this case downcasted, this is called downcasted, to a subclass of that thing so I can interact with it as that subclass. Okay? Same thing happens here with protocols. We could have done that same thing with the car and the movable. We could have had a movable var and tried to cast it as a car. And if we were successful, then we could send it change oil. But if it was a shape and that failed, it would return nil and we would not be able to do it. Okay? So you're going to see us doing this casting, not as much with any, some with any, but a lot of times just downcasting because we'll have some function that takes some superclass and we pass a downcast, a subclass into it and we're going to downcast it to look at the subclass in case it is that subclass and then we can send it messages. All right, so that's it for any and casting. The last slide I have here before we dive into views is just 4 other interesting classes that you should know about in Foundation. One is anyobject. anyobject is the root class of all classes from Objective-C. Okay? All the things like UI view controller, all the UI kit classes, all those things that were developed in the Objective-C world and are compatible still with Objective-C, their root class, the thing they inherit from eventually at the top, is anyobject. In Swift, no requirement to subclass from anyobject, although there's a few tiny esoteric APIs that ask you to pass a class in that has to implement anyobject. And I'll explain them to you when we get to it. But normally your Swift class, like remember concentration, that class, we originally made it, it didn't inherit from anyobject. It didn't inherit from anything when it was a class. We converted it to a struct later. And that's perfectly legal in Swift. That was not true in Objective-C. In Objective-C, pretty much all classes had to inherit from anyobject because some of the runtime was built into this class rather than being in the actual runtime like it is in Swift. Okay, second interesting class is NSNumber. In Objective-C, when you pass numbers around, you actually pass them with this class, NSNumber. It's a class, so it's a reference type. Okay? You didn't have double and int as classes. You had C-like doubles and ints in Objective-C. but you didn't have that. So you had this, if you wanted to pass something in an object-oriented way, you had to pass this NS number. Now, it can represent any kind of number, floating point number, integer, anything. Okay, it's a kind of a generic number holder, even a Boolean it can hold in there. Now, what's really awesome is all the API throughout iOS that takes an NS number, and there's a lot of it, automatically bridged to the Swift types. Okay, so if you have an Objective-C based API somewhere in iOS that takes an NS number as an argument, you can pass a double in there, okay, or an int or whatever it's expecting, whatever it's supposed to be. You don't even tell, you won't even know, you won't even see NS number because the documentation is already being converted as well to show you. And similar, when things come out, if something comes out of the API as an NS number, you can work on it as a double or an int or whatever is appropriate, and it works just fine, okay? But I just mentioned it in case you see it and wonder, what is that? It's this old Objective-C generic number holder. It's easy to create one from a double or an int by just using an initializer, right? NS number sub 35.5. That's going to give you an NS number with the double 35.5 in it. And you can get the values out with vars on the number, like int value, double value, bool value. They'll give you the return in a Swift type, double, int, bool, whatever. Okay, date, some of you already know about date because you did the extra credit maybe in assignments 1 or 2. Date is just a way to represent any date in time. You know, internally it's represented, I think, like number of seconds since 1970 or something like that. It's great for doing that. It's great for even small amounts of time because the date includes the time down to small, you know, sub-millisecond times. But I just want you to note that with date, there's other classes that go along with it, like calendar, date formatter, date components. Date components will give you things like the month and things like that. And why are there all those other classes? Well, because date, if you're going to put it in your UI, you have to be very careful. Around the world, dates are represented very, very differently. And it's not just that the name of a month is different in a different language. It's that other locales, we call them, around the world, use completely different kinds of dating systems, maybe even a completely different calendar than we use, okay? So you really have to be careful if you're going to put dates in your UI to understand all these other classes. And there's plenty of documentation how to do it, but it is extra work. Now, if you're just using date internally to like keep track of how long your concentration move or set game move is taking, okay, obviously you don't need any of that other stuff. And finally, there's data. Data is just a bag of bits. Okay, we use it to transfer data around a lot inside iOS API. For example, if we got an image from the internet, from some URL, it would come in as a big bag of bits. And we have classes like UI image, which I'm going to talk about today, that can look into the bag of bits and say, oh, that's JPEG data, and make an image out of it. Or look into a bag of bits. You know, we have formatters that look and say, oh, that's JSON data. Everyone, who knows what JSON is? Raise your hand if you've heard of JSON. Okay, great. So that's JSON data, and it would interpret it as JSON data. So that's what this data struct is. It's just a bag of bits. Okay, and there's lots of methods to convert it to and from other kinds of things. Okay, that's it. So that's all I wanted to mention is those quick things. Now we can dive into our main topic today, which is a really cool one, which is views. All right, so I don't want you to be confused about the word view. I'm using it in two contexts. One is MVC. One of the letters there is V for view. That means that bunch of generic minions of your controller. That view, capital V view, contains a lot of views. These views that I'm talking about. And by these views, I mean a subclass of the iOS class UI view. Okay? So that's what we're going to talk about today is these views, these things in an MVC's view. Sorry for the terminology being the same there, but same word, somewhat different meanings there. Okay, so what is a view? What is a subclass of UI view? It's essentially just a rectangle on screen that defines a coordinate system. And this is a coordinate system you're going to use to draw, and it's also a coordinate system for getting multi-touch events, right, with the fingers on the screen. It's hierarchical, which means these rectangles live inside other rectangles, right? So the views inside views inside views. And you saw this with concentration. We had that top level view, which was black. And then inside that, we had stack view, remember that? So that was another view. Inside that stack view were 3 more stack views. Inside those 3 stack views were 4 card buttons. Those were UI buttons, right? Plus you had other views like your new game button, score, flip count. Those are all views, and they are all kind of in each, in a hierarchical representation. So the way that if you look at a particular view and you want to see who its super view is, in other words, the view it's in, you just ask the view for the var super view. Okay, now it's an optional UI view because it might not currently be on screen, right? So it might not be in a super view at this time. You could certainly add it. And then the other way around, if you have a view and you want to say, what are all the subviews in it, like you want to ask our black view, where show me all your subviews like this top level stack view and the flip count label and the score and the new game button. You get that with another view var called subviews, which is, as you can see, an array of UI view. Okay, so it's very simple to manage this. There is also a UI window, which is like way up at the top, but we never pay any attention to that in iOS. Okay, it's not like the Mac where you have lots of windows on a big desktop. The UI window, the only time you probably ever care about that, maybe if you had an app that like projected part of itself out onto an external screen or something, okay, but forget that. So in this class, we won't even mention UI window, okay? It's probably a subclass of UI view anyway, but we don't really talk about it. Now this hierarchy of views inside views, you build it in Xcode, in Interface Builder, right? You saw how we built it in concentration. We dragged things out, we clicked on the embed in stack view button, that kind of stuff. So that's how we build this hierarchy, put views inside views 99% of the time. But it can be done in code as well. And in your assignment 3, I'm going to ask you to do both, build view hierarchy in Interface Builder like you did in concentration, but then also do some in code as well. And the way you do that is by just saying add subview to a view, and it will add that view as one of the subviews. The only tricky thing here is when you want to pull it out for some reason, if you want to pull a view out of the view hierarchy, you send that message to the view itself, okay? You send it to the view you want to remove, and you say, remove yourself from superview with this, remove from superview, okay? So it's a little different there. You send add to the enclosing view, but you send remove to the actual view itself. Now, where does this view hierarchy start? What's the top containing view? Well, of course, that's like the black view in concentration, right? That very top view. And there's a very important var in UI view controller called view, okay? And that view points to that black one at the top. And it's automatically wired up for you in Interface Builder, so you can always start there and kind of work your way down the view hierarchy, looking at the subviews and going on down, okay? So var view, which is a UI view in UI view controller, very important var to know if you want to access your view hierarchy directly. Now, of course, you can also access your view hierarchy at any point with an outlet. Right? If you create an outlet, like to a stack view, now you can look right at the stack view, okay? And start looking at its subviews if you want. You don't have to start at the top and start looking down. You can use an outlet to go to any view you want at any time. All right, let's talk a little bit about initializing a view, right? Getting it initialized. Normally, as usual, we try to avoid doing init, okay, as much as we can with all those other ways we know. If you have to do a view initializer because it's just a var that you just no way you can initialize it using all the other ways we know, then you have to understand that view has two initializers, init with frame and init with coder. Init with frame is the initializer you use to create a view in code. Init with coder is the initializer that's used when you build your view in Interface Builder and it gets freeze-dried, and then your app runs. When it runs, it gets initialized with init with coder. Okay? The coder, NS coder, is a protocol that handles this mechanism of freeze-drying what's in Interface Builder and then resurrecting it when your app runs, okay? So you have to implement both of these. And the reason you have to implement both of these is because init with frame is a designated initializer, okay? And so if you ever created a view from code, you need, if you want your code to execute, it's going to have to do it. And then init with coder is a required initializer because it's part of a protocol that UI view implements, this NS coder protocol, you see. You remember, if you implement a protocol and it has an init in it, it's required, okay? So you'd have to implement them both. Now, you could have some other function like setup or whatever and call that setup from them both, although sometimes it's not that simple because if you're using this mechanism to initialize your own vars, you're supposed to initialize your own vars before you call super init, okay? So you're going to have to initialize those vars inside these inits. Maybe you might have slightly duplicated code there doing that. But hopefully you can avoid this init in UI view entirely. Okay, another alternative to initializing a UI view is awake from nib. Now, awake from nib is actually a function that's sent to every single object that comes out of an interface builder file. Okay, every UI button, every UI view controller, everything that comes out of there, when it gets unfreeze dried, it gets sent awake from nib. Now, the only thing about putting initialization there is it will only work for views that come out of an interface builder file. Okay, if you create a view with init and frame from code, if you create one, this won't get called. Okay, this only happens when you get unfreeze dried from interface builder. Nib is kind of an really old name for interface builder files. Okay, the IB in nib means interface builder. Okay, so that's it for initialization of views. All right, now let's talk about how we draw. Okay, we have this UI view. Why do we want it? Well, we want to draw. How do we draw? Well, before I can tell you how to draw, we got to talk about some types. 4 very important types. Okay, they all start with CG, like this one, CG float. CG stands for core graphics. Okay, core graphics is the underlying drawing system for normal 2D drawing in iOS. There are other drawing systems. Okay. For doing 3D and other things, I'm not going to talk about those because I only have so much to talk about. We're just going to talk about the base 2D drawing system, and it's called core graphics. Okay? So core graphics has these 4 types that are just critical to being able to say anything about drawing. One is CG float. So all drawing is in a coordinate system that's floating point numbers. Okay? So you're drawing in a floating point coordinate system, not integers, they're floating points. When you say where you want to draw, every point you're doing with floating point numbers, and those floating point numbers have to be CG floats. They cannot be doubles or regular floats. They have to be CG floats. Luckily, there's an initializer for CG float. We'll let you create a CG float from a double, but CG float is the fundamental kind of coordinate value, a floating point coordinate value. All your code that's drawing is going to have CG floats. Now, of course, there's CG point, which is just a struct with 2 things in it, x and y, which are both CG floats. And there's CG size, which is a struct that has 2 things in it, 2 CG floats, width and height. Okay? So you got float, CG float, the base thing, then you got point and size. And of course, you can combine point and size into very important CG rect. Now, CG rect defines a rectangle, obviously, including your view's entire bounds, that rectangle, or any rectangle you want to draw inside your coordinate system, you're going to use this. And it has a number of initializers, including initializing by origin and size, also initializer that takes x, y, width, height, etc. And it also has a whole slew of other vars and functions for manipulating rects, like vars like min-x, which gives you the minimum x value of your rectangle, or intersects that takes another rect and returns a bool whether the 2 rectangles intersect. There's also intersect, which returns a new rect, which is the intersection of 2 overlapping rectangles. It also has contained CG point, which will tell you whether there's a point. That point is inside this rect. Okay, so there's probably 2 or 3 dozen methods, so definitely check out the documentation of CG rect because it'll make your code a lot cleaner. And actually, you're going to see in the demo that I do on Wednesday, I actually even extend CG rect to add 5 or 6 more little convenience functions because CG rect turns out to be so important in all the code that you write, okay, when you're doing drawing. Okay, so now you know those 4 types. Let's talk about the coordinate system we're going to be drawing in here. The most important thing to know, besides the fact that it's floating point precision to draw, is that the origin is in the upper left. Okay, upper left, not lower left. The lower left would be Cartesian coordinates, you know, like you have in math class. Lower left also happens to be the coordinate system on the Mac, okay? But in iOS, it's in the upper left. And that means that increasing values of y go down towards the bottom of the screen. So for example, I got this point over here on the side there. See it up there? 535. It's 500 over and 35 down, right? Way over and way down. So that's x of 500. And it actually really would be 500.0 and 35.0 because they're floating point values, right? Okay, the units in this coordinate system are called points. Points are not the same as pixels. Okay, pixels are the little dots that the screen is made of. Some screens have a lot of little pixels, okay? Very, very high resolution, what we call retina displays. You've probably heard that phrase. Lots of pixels per point. Why is that good? Well, because remember, you can draw on floating point boundaries, so you can draw at 27.3, 27.6, 28, right? You could be drawing in between points, and you get these very smooth curves or whatever on a retina display. On a lower res display, maybe there's only 1 pixel for every point, and so it's kind of more jaggy when you draw, okay? But you don't draw on pixel boundaries, you draw on point boundaries. That way, even if you got a lot of pixels per point, it looks the same size, basically, as on a lower resolution device, okay? It's not as smooth as on a high resolution device, but it's the same size, okay, because it's in points. You can find out how many pixels per point your device has by using UIView's content scale factor. It returns a float. It's currently going to either be 1, 2, or 3, and it's going to tell you how many pixels there are per point. All right. The most important rectangle in all of UIView is bounds, okay? It's a var on UIView. It's a CG rect. It tells you the bounds, the coordinates of your drawing system, the origin and the width and height, in your own drawing coordinate system. And one thing you're going to have to understand is different views have different coordinate systems, okay? They each have their own coordinate system. This bounds is in yours. So when you're drawing, you always use bounds. Now there are a couple of other things like frame, okay? Var frame sounds a lot like bounds. Frame has nothing to do with your drawing. Nothing. It's a rect, but it has nothing to do with your drawing. The frame is where you are in your superview. So frame is not even in your coordinate system. It's in your superview's coordinate system. It says where you are. Similar with center. Center is not the center of your drawing area. It's the center of you in your superview. So frame and center are where you are. Bounds is the place you're drawing. Okay? Don't get these things confused. I have a slide on it here. Go through it quick. We never use frame or center to draw because it has nothing to do with drawing. It has to do with positioning. And you might think that the frame and the bounds are going to be the same size, but views can be rotated. And if you imagine rotating your view, the bounds get rotated with, okay, so they stay the same size, but the frame now has to get bigger to totally enclose this because it's a diamond-shaped, right? View B is a diamond shape. Okay, so the frame's size, width, and height are not the same necessarily as the bounds size of width and height. And don't ever think of them as the same. If you ever use your frame to draw in this class, you'll get dinged. Okay, that is just wrong. Okay? All right, so now we know the bounds of where we're drawing. We know we have this coordinate system in the upper left. Okay? How do we create one of these views? Okay, we want to create one. Well, I told you that you mostly do it in Interface Builder, but if I have a custom view, let's say I have a custom view draw something special just to me. How do I drag that out into Interface Builder, right? Interface Builder's got that nice list in the lower right corner of UI button, UI label, all those cool things. My view's not going to be there, right? So how do I make one? Well, it turns out you drag out a generic one. Currently, as of this my speaking, it's the second from the bottom in that long list. It's called UI view down there. You drag a generic one out, and then you're going to inspect it. But you're going to use a little different inspector in the upper right than you usually do. It's not the attributes inspector, it's the identity inspector. I think it's the tab just one to the left of the attributes inspector. And in there, the top thing is going to be the class of the thing you're inspecting. And it's going to be UI view when you first drag it out. And you're just going to change the pull down there to pick your class. So now you have a view there, but it's of your class. That's how you're going to create one of your custom views. Okay? Now, the other way you can create views is in code. And again, I'm going to ask you to do this both ways in your assignment 3. And you do that just by calling the frame, UI view with frame initializer that we talked about before. You can also say UI view, open parentheses, close parentheses. Then your frame will be 0, 0, 0, 0, upper left, no size. And you can then just set that frame var that I talked about a couple slides ago to position and size this view in the super view. Okay, just always remember the frame, though, is in the super view's coordinate system. It's saying where you are. Nothing to do with your drawing, just where you are. Okay, so here's an example. I'm going to create a UI label in code. Okay, UI label, you know what that is, right? It shows text. That's like the thing that said flipped :0. That was a UI label. Of course, UI label inherits from UI view. It's a rectangular area on screen. All rectangular areas on screen are UI views. So I'm going to create a rectangle to say where it's going to be. This rectangle is going to be in the super views coordinate system. In this case, I'm going to put the label at the very top level. In other words, the black view of concentration. I'm putting it right up at that level. So this 20 across and 20 down and a width of 100 and height of 50, that's in the black views, the top level views coordinate system. Then I create a UI label using that frame. Okay, I set the label's text to hello. Nothing's happening on screen right there, yeah? Now I need to add it as a subview of that black view. So I'm going to assume this code is in a view controller, and I'm going to use that very special var view and say view, add subview this label. Okay, now that UI label gets added as a subview of the top level view, the black view in concentration, it's white here, and it gets put at 20, 20, 150 in that top level views coordinate system. And remember, upper left is 0, 0, so that means down from the upper left corner. Everybody got that? So that's how you add view. It's very easy. Just add subview. That's how you put a view on screen from code. All right. So when would I want to create my own UI view subclass versus just using UI button or UI label? Those are UI view subclasses. Well, if I obviously want to do custom drawing, or if I want to handle some custom touch events, pinches or something like that. I'll talk about handling touch events on Wednesday, but today we're going to focus on drawing. Okay, so we're going to do all drawing today. So to draw, it could not be easier. There's only one way to draw, okay, in all of iOS, which is you override this function in UI view and implement it. That is the only way to draw. Okay, you can't call any functions that draw or anything outside of this method. It's the only way to draw. So that makes it really simple. You don't have to worry about any other mechanism because this is the only one there is. And so inside this draw method, you're going to draw in your bounds whatever custom drawing you do. Okay? Never call this method, ever. Okay? This method you override and implement your drawing. You never call it. If you want your view to be redrawn because something about you has changed, you call one of these two methods on yourself. Set needs display or set needs display with rect. Okay, and that tells the system, hey, my view needs to be redrawn. Please redraw it. So only the system, only iOS calls your draw. And you can make it call it, or tell it you want it to call it anyway, by calling set needs display. Now notice this rect. See the draw rect? What is that rect argument both up on draw and down in set needs display? That is purely an optimization rectangle. Okay? That's if, for example, you had another view on top of you and it went away and it exposed a little rectangle of you, the system would call your draw with just that rectangle. But you are allowed to redraw your whole view if you want. But if you can be efficient about only drawing the rectangle that was exposed, then you can be efficient. Okay? So it's purely an optimization. You can ignore it if you want. Just draw your whole view. So if you have a simple view that's easy to draw, doesn't use a lot of resources, not 3D graphics or something, then you can just ignore that rect. Okay? All right, so how do I implement this draw rect? Okay, I override it, now I want to draw. So how are we going to do it? We're going to do it using core graphics, okay, this underlying drawing level layer. And the basic way to do it is you get what's called a drawing context, and you ask that context to draw lines and stuff, okay? Now, there's also an object-oriented way to draw with a class called UI Bezier path. UI Bezier path, same concept, it's just putting a little bit of an object-oriented way. You can build an object that contains some drawing, which is nice if you want to repeatedly draw that object, maybe with different colors, whatever. So let's talk about the fundamental core concept of drawing in core graphics. How do we do it, okay? The number one thing about core graphics is that it's context-based, so you have to get a context. UI Bezier path will automatically get the context for you, but if you don't use UI Bezier path, you have to get a context. Now, in draw rect, you can use this Swift global function, UI graphics get current context, and it will give you a context to draw, okay? But there could be other contexts, printing or drawing in an off-screen buffer, when I'm not going to talk about those, but there are other ways to get context as well. But when you're in draw rect, it's easy. You just call this one global function. It will give you the context you are currently drawing in. Okay, once you have the context, now you use the context to create what are called paths. Okay, paths are just arcs and line twos and then move twos, which is like jump over a little bit. It's just a combination of all those. Okay, that is what a path is. So you're going to build some path. Then you're going to set a bunch of drawing attributes like the color you want to draw in, any fonts, kind of, that's a drawing attribute. We'll talk about fonts in a bit. But line width, textures, things like that, you set all those things up, and then you do one of two things with your path. Okay? You stroke it or you fill it. So stroke it means draw a line along my path, you know, with a certain line width and color. And fill means fill in the area that my line encloses. Okay? Believe it or not, this is the only way to draw, okay, basically, in core graphics. And you might be like, wow, that seems really limiting. All I can do is arcs and lines and fill them in and stroke them. But it's amazing what you can do when you build on top of that primitive, powerful mechanisms, okay? And we'll talk about that. So UI Bezier path does the same thing. It just does a lot of it under the covers. But it has methods for setting the line width and things like that. And it has a method to stroke and a method to fill and a methods to do arc 2 and line 2 and all that thing, okay? So it's just a kind of an object-oriented collecting bag of that. So let's look what the code looks like to draw a triangle using this mechanism, okay? So first I'm going to do it with UI Bezier path. I'm going to create a UI Bezier path. It has a lot of initializers, but I'm going to use the one that just creates an empty path, okay? So it creates a new one, there's nothing in it. Now I'm going to move around. I'm going to start by moving to a point, you see, that's 80 across and 50 down. Let's assume that this screen is 160 points across and, you know, 300 or 400 high. So I'm moving halfway across and 50 points down from the top. My origin is upper left. Now I'm going to add a line down to 140 over almost to the edge of the screen over there and 150 down. Then I'm going to add another line. See how I'm just calling functions on my UI Bezier path to add lines, right? So I add another one over here. Then I'm going to close my path. So there's a method in UI Bezier path called close that just draws a line back to where you started, okay, wherever that was. So I'm close my path. And there's tons of methods in UI Bezier path. You have to go look at the documentation. But here's simple, those are simple method usage, right? Now I kind of been tricking you because you look at this and it looks like as I call these, it draws on screen. But no, okay? I just wanted to kind of give you visualization of what's going on. In fact, when I did all that, nothing happened on screen, okay? There's absolutely nothing happening. All I was doing was building this UI Bezier path object up. If I want it to appear on screen, I have to set my drawing attributes and tell it to stroke or fill. So let's do that. Now we set our colors, both our fill color and the stroking color, using the UI color class. Okay? So we don't set it on our UI Bezier path, we actually use color, and we say things like UI color.green set fill. Well, green is a static var on UI color, meaning it's a class, like a class color, okay, just like get unique identifier was in card, okay? And it just gets the green color. And it has about 10 or 12 predefined colors, red, green, blue, magenta, cyan, that kind of stuff. We could also make colors, we could use a color literal there. Remember when we did the color literal? Perfectly legal to say color literal dot set fill. So we're setting our fill color and our stroke color. So we're going to fill with green. Our triangle is going to be filled with green, and the line is going to be drawn with red. And I'm also going back to the Bezier path and saying set the line width to 3 points wide. On a high resolution display, that would be 9 pixels wide. Okay? So it's a fairly thick line, not that thick, but. So now that I've set these things up, now I can stroke and fill. So let's first fill. And when I fill, I get this. Notice there's no line around the edge. I just get the fill of my path that I made. And then when I stroke, now I get the red 3-point wide line around. Yeah? Where is this written? Like where do you put this? In your draw rect. In that draw method that we override in UI view, that's where this code goes.
And so when I drag a UI view onto the storyboard, do I have to make an outlet to have...
Okay, so the question is, when I drag a UI view out into my storyboard and I set it to my custom class, do I have to like do an outlet or something? No, you just in your custom code implement your draw with that kind of that optimization rect argument and put this code in there. And every time the system has your view on screen, it'll draw this. Now it's very efficient. It's only going to ask you to draw once unless things change, but it's going to draw it for you. So all of the drawing is on demand, right? The system asks you to draw, it calls your function, you implement this code, and it draws on demand. Okay, you never force draw. The only way you can kind of force drawing is that set needs display, and even that's just telling the system, please draw me as soon as possible, but not instantly. Okay, it's all on demand drawing. Okay, so this is how you would implement this code would be in your drawRect. We call it drawRect. It used to be called drawRect. Now it's called draw underbar rect. But I suppose we could call it the draw method, but we call it drawRect. It's got that rect argument, okay, that optimization, okay? All right. Now, you can use UI Bezier path also to create some very common paths, like a rounded rectangle, which we'll use in our demo because we're going to do a playing card, okay, which has a rounded rectangle. You can also do circles, ovals, things like that, using other initializers of UI Bezier path. Note that you can use your Bezier path to clip your drawing. You'll definitely want this for your homework. Pay attention here, okay? So what that means is you draw some shape like your triangle, and if you send add clip to your path, now all future drawing will be inside that triangle. Even if you draw outside, anything outside gets clipped off, okay? So that can be really convenient for your homework. That's my hint for you, okay? You can also do hit detection, like is this point in the triangle, right? Using this contains point method, and lots of other stuff. So check the documentation for UI Bezier path, all the things you can do. All right, let's go talk about UI color, right? Okay, for setting the fill and stroke and stuff like that. We know a lot of ways to create colors, color literals, also these static functions I mentioned. You can also create them with initializers that take RGB values, or HSB, which is hue, saturation, and brightness, or even a pattern. Okay, you can create a color that's actually a pattern, some image, okay, that's like repeated, which is kind of cool. And we also know that views have a background color, right? We set the background color of our base view in concentration to be black. We set the background color of our buttons to be orange, so there's a var for that, of course, in view. Colors also, importantly, can be transparent, okay? A transparent color, you can kind of see through it a little bit. And we specify transparency using something called alpha. Okay, how many people have heard the term alpha with drawing? Okay, so most of you know this, great. So we use alpha. Alpha of 0 means fully transparent. Alpha 1 means fully opaque, and we can have any number in between. The way you get a transparent color is take a color you've got, like yellow, let's say right there, and you send it the message or the function with alpha component, and it'll give you a new color that has that transparency. Now you can draw with that transparency, okay? If you want to draw in your view with transparency, though, be very careful, because the system assumes by default that your view only draws opaque, okay? It only draws with fully opaque colors. If you actually draw with transparent colors, you have to set a var on the view called opaque to false. Now, why does it do this? Well, imagine how much more CPU and GPU intensive it is to draw with transparency, because now the views behind you have to be composited with your bits, okay? And you know the compositing, not cheap, all right? Your GPU got a lot of work to do there. So that's why the system assumes everything's opaque and that every overlapping doesn't have to be composited. And so if you want to draw with transparency, which is fine, it's legal, it's not that expensive that you would never want to do it, but just make sure you set this opaque to false. And you can do this in Interface Builder. Okay, you can click on the view, and one of the things in the inspector over there is whether it's opaque, and just turn that off. By the way, you can make your entire view transparent if you want by setting its alpha. So views have alpha. That means all your drawing in there will be somewhat transparent. That's kind of a cool feature. Okay? All right, brief mention about layers, okay? So UI View's drawing mechanism, okay, is actually built on another whole system I'm not going to talk about called core animation. And that's because everything you do in a view can be animated, okay? Views moving, transparency happening, all this stuff can be animated. And there's a whole layer for doing that. And so the UI View, we see a top-level API for it, but there's actually a whole other API for drawing called the CA layer, Core Animation Layer API. And I actually mentioned this in the hints of assignment 2. You've already seen this. There's this var in UI View. It's in button because button's a UI View, called layer, okay, which gives you the layer, the CA layer, that's being used. Now, I'm going to talk all about animation, hopefully next week, maybe the week after, and we'll get into some of this stuff. But you already know from assignment 2 that there's a few really nice vars in the CA layer, like corner radius, if you want to put a rounded rect on your view, or the border width and border color. By the way, you notice that the border color there was a CG color, not a UI color. Okay, CG color means it's a core graphics color. Why is that? Well, that's because this whole layer mechanism, core animation, is below the UI kit layer and built on top of the core graphics layer. So it can't really use the UI color struct because it's kind of above it in the hierarchy of frameworks depending on each other. So it uses CG color. Luckily, UI color is also above core graphics, so it has a var called CG color, which gives you itself as a CG color. And I showed all that in the hints of your assignment, right? Okay, so that's a layer thing. We'll talk about more about animation later. Let's talk a little bit about the transparency and how that works, like which views are in front of which other views, right? If I have a transparent view, and it shows the one behind, which is behind. That's all determined by the order of the subviews list, okay? Right? Any view that has subviews has an array of them. The first thing in that array is the back, and everything else is one step in front, okay? The last thing is the one in the very front. So if you have multiple subviews of your view and they overlap, okay, it's the one in back is the first one in the subviews list. So you can reorder the subviews list and move them. Okay? Move the one from the front to the back or whatever. So you can control that transparency effect. Also, even if there's no transparency, if the views are on top of each other and they happen to overlap, a lot of times when we have multiple subviews, they're all side by side, they don't overlap, but they could, they could overlap. And if they did, then that subviews will tell you the order, which ones are in the front. Okay? You can completely hide a view without taking it out of the view hierarchy with is hidden. If you say to a view, this is a var on view, if you say view is hidden equals yes, it will not appear on screen. It'll still be in the view hierarchy, still in the subviews list. It'll still have a super view, but it won't there, and it won't get any gestures either. So you won't see its drawing, you won't get any gestures. It'll be hidden. And you'd be surprised how common it is to want to do these, okay? You put a view in the view hierarchy somewhere, you hide it, then when some condition is true, it appears, probably animated, okay? Things appear. That's a common way to build an interactive UI. All right, so we know how to draw with these arcs. What about drawing text? Well, actually text is just some font designer move to, line to, curve to, okay? That's all the character, every character in a text is just a bunch of little move to, line tos. Luckily, some font designer somewhere did those all for you, or that would be incredibly tedious for you now, wouldn't it? So we want to be able to draw, though, using these wonderful move to, line tos, which are the glyphs, okay, in a font. So how do we do that? Well, before I even dive into that, remember that UI label draws text real well, and there's no reason you couldn't make a UI label be a subview of your view and thus draw the text that way. Okay? That's a great way to draw it because UI label's got all the incredible amount of center text alignment, and you can control the color. You could put an attributed string on that label. You got complete control with that. Okay? The only thing is you have to make sure that you keep that UI label's frame in the right spot, okay, in your subview. You know, it's one of your subviews, so you've got to make sure its frame is kept in the right space. But that's a great way to draw text, so don't forget that, okay? But I will talk to you now about how to draw in your draw rect, and you use attributed string. Okay, so you just create a attributed string, and you send it the message draw. And it will draw at the point you say in your current context. So drawing text could not be easier. You already know how to do an attributed string. So you just create an attribute string. Here, my attribute string doesn't have any attributes here for slide space issue. But you put your attributes on it, whatever, and then do draw at. You can also do draw in, and it'll draw it in a rectangle in the upper left corner of the rectangle. And then you can also get the size of the text by just asking the attributed string, what is the width and height necessary to fit this attributed string, okay? So super easy to draw text in your draw rec. You just use attributed string. Now, I wanted to take a little time here about attributed string and circle back to what I said about it before. Remember I talked about how NS attributed string is an old objective thing, and it uses NS string, and then we're using string, and string uses kind of a different encoding for Unicode characters, and sometimes mapping between NS string and string, the indexing is different because we've got wacky characters like emoji that are actually multiple Unicodes. Ugh, that whole mess, you remember that? Well, I'm going to tell you a little bit how to get around that. You don't need it. You didn't need it for assignment 2. You won't need it for assignment 3. Maybe I'll ask you to do it for assignment 5, okay? But if I do want to set attributes just on certain characters in my attributed string, and it's a string, not an NS string, how do I do it? Well, the answer is this class right here, NSRange, okay? So NSRange is the way you specify a range into an NS string, okay? So this is an old Objective-C way of doing a range. In our world, we do range of string index. That's how we index into a string, right? Because we know that strings are indexed by string.index, not by int. So we have this wholly different thing, range of string index, and here attributed string wants to do an NS range of int, because NS string was indexed by int. Okay, so how do we get from range of string.index to NS range of an int that matches, okay, so that the NS attributed string matches our string? Well, we do it with NS range. We do it with this right here. This is NSRange initializer. You see it, NSRange initializer. It takes this first word range, which is a swift range of string.index. You see it goes from start index here over to index of. So it's a range. It's got the little dot dot less than, which is our nice range syntax there. So it takes a range and it converts it into an NS range, but it needs to know the string that those string.indexes are into, right? So the combination of knowing the string and the string.index range, it can crunch on that and change it into an NS range that will work in an NS attributed string. So that's the magic. Okay, NS range, use the initializer that takes a range of string.index and a string. It'll give you back an NS range. Now you can call methods like in attributed string, like add attribute, which adds a single attribute at a certain range of characters. And look at the argument range NS range. Now you have an NS range to give it. Okay? All right, fonts. Okay, fonts, incredibly important in iOS. I cannot overstate how important fonts are to the look and feel of iOS. These are, I think, are iOS 10 screenshots, and iOS 11 things have changed slightly, but not too much. But even in these screenshots, you can see how important fonts is. They really make a difference to how your UI looks, okay? So you have to pick the right font. So how do we pick fonts? Well, in iOS, the most important concept with fonts is preferred fonts. Okay? There are about 10 categories of fonts, like body fonts, headline fonts, caption fonts, footnote font. Okay? So there's these kinds of fonts. And you need to pick one of those preferred fonts for whatever environment your text is in. Right? If you're showing main information, then it's probably the body font. If it's a little caption of a image, you're going to use the caption font. Okay, so you've got to pick the right font and use it. Now, this is really easy to do in Interface Builder. You just pick your label or button or text field or whatever you're doing, and you go to the inspector, and where it says font, instead of choosing system font, which is what we've always chosen because I hadn't talked to you about preferred font, you choose one of these things, body font, caption font, footnote font, etc. Okay? In your code, you can do the same thing, and you do that using this static i.e. class type method in UI font called preferred font for text style. And that text style is headline, body, footnote, whatever. This will give you back a UI font that you can put in your NS attributed string dictionary. Okay, one of the keys in there is the font, and you can use this as the font when you're drawing text in your draw rect. Okay, now one thing to be concerned about here is that the size of this font is variable. Okay, you get old people like me, okay, we're starting to hold our phones like this as the years go by because it's hard to, our eyes are giving it, so we like the fonts big. Then we can hold it a little closer and see our fonts. Well, the way we do that is we go into our settings on our phone, and one of the settings under general there is accessibility, and we can say larger text, and we move a little slider, and now all the fonts get bigger in all the apps. But only the apps that play this game right, okay, and use preferred fonts. So you want to be one of those apps. Otherwise, you're going to lose the older folk from your demographic, okay, of your people buying your app. So it's important to make sure that your UI also works when fonts get bigger and smaller. And the number one way to do that, auto layout. Okay, you know that auto layout where we put constraints, pin things to the edges. You want to use good auto layout so that as fonts get bigger and a text field gets bigger, the other things push out of the way and it uses the screen real estate properly. Okay, so you've only seen a little bit of auto layout. I'm going to show you more auto layout at start of Wednesday's lecture. You can see more and more as the quarter goes by, but that's a good way to make it work. Okay, now what if you either want to use some other font, some special font that's something that's maybe part of your marketing or whatever, or you want it to be bigger, or smaller, I guess, than the standard size font that comes with a certain preferred font. Okay, well, UI font does have a way to create a font by name, like if you want Helvetica 36 point, you can say UI font, name Helvetica, size 36. Okay? And there's also a class called UI font descriptor. Has a lot of cool ways where you can take a font and say, give me the bold version of this, give me the italic version, okay, all that stuff. So you can get your font this way. But if you do your fonts this way, you still want, when I go into my settings and make my font bigger, you want your font to get bigger. And look what size font this is, 36. It's fixed. So I need to somehow scale this font up if the user has put their slider to bigger. And the way you do that is with font metrics. Okay? So you create a UI font metrics object for the text style, body, footnote, caption, whatever. And then it has a very cool method called scaled font. And you give it a font like Helvetica 36, and it will give you back a new font, Helvetica 42 maybe, that's scaled based on what the user said. Okay? Don't skip this step. Okay? Otherwise, if you use a custom font, when people move that slider, your app's not going to work, and people are going to be like, I hate that app, I can't see any of the text and it's too small. All right? There are also system fonts, okay? So we use those so far in our concentration demo. That's only for things like button titles and stuff like that. That's not for user content, okay? Stuff that the user has generated or requested or something like that. Those are preferred fonts. System fonts are just for like buttons, things like that. Okay, what about images? We know how to draw lines and arcs. We know how to draw text. What about drawing images? Okay, just like UI label for text, there's another one called UI image view, which lets you add an image as a subview. Okay, so you could use that to draw an image in your view if you wanted. Just do it as a subview. But if you want to draw an image in your draw rect, you can do that too. You need a UI image object. A UI image represents an image. JPEG, TIFF, whatever kind of image, it represents an image. Now, how do you get an image? Okay, there's a bunch of ways to do it. One way is to drag the JPEG file or whatever into that assets.xc assets file. Remember when we were doing our demo and I put some things off in supporting files, one of the things I threw in there was the place where the app icon was. Well, you can drag other images in there, and along the left-hand side will be all the names of them. And then you can call this method right here, UI image named whatever, and it'll go look in that assets thing and find an image with that name. Now, this is a failable initializer. It can return nil, and that's because it might not find that particular image in there. Okay, so you have to say usually if let to do that. How else can you get an image? Well, you can get one from the file system. If you've got a JPEG in the file system, I haven't told you how to access the file system, so you're not going to be doing that. I'll show you later. You can also get it if you have a bag of bits that you got over the internet, right? The data that has a bag of bits with JPEG data in there. UI image knows how to look in that bag of bits and figure out if it's an image. You can even use this global function UI graphics begin image context and then draw arcs and lines, and it'll capture it as an image. Okay, so you can even draw a custom image if you want. So anyway, you do one of these things, and now you have a UI image in your hand that represents the image you want to draw. How do you draw it? Exactly the same as NS attributed string. You just use draw at, which will draw the image with its upper left corner at that point. But you also can do draw in a rect, and it'll scale the image to fit in that rect. So that's a cool way to scale your image up and down. And you can do draw as pattern, which will tile your image repeatedly. Repeat your image to fill the rectangle. Okay? Super easy to draw images as well. All right, let's talk about your bounds changing. Okay, I've got my draw rect. It draws beautifully, but now my bounds changed. Okay? And when would this happen? Well, number one way, your device got rotated. Okay? They were looking at you in portrait. Whoop, they rotate you. Now you all of a sudden went from this tall, thin view. Whoop, now you're this wide, very short view. Okay, your bounds have completely changed. You went from a width of maybe 200 to a width of maybe 700, and from a height of maybe 300 or 400 to a height of 150 or 200. So that's a major change. You're going to have to redraw all of your stuff, usually. Unfortunately, that's not the default. Okay, in iOS, when your bounds change like that, it does not redraw you, believe it or not. It takes all your bits and squishes them. Okay. So it looks absolutely terrible most of the time. Okay? It just smashes the bits, squishes them down, stretches them out to fit your new bounds. Okay? Which you almost never want that. Okay? So how is that controlled? That's controlled with a var in UI view called content mode. Okay? And the content mode is just basically saying, what kind of content do I have? Do I have the kind of content that can be squished and scrunched like that and still look good? Or do I have the kind of content where I have to be redrawn when my bounds changes? So there's 3 different categories of content modes. One is keep my bits, okay, don't redraw me, but just move my bits unscaled to a new position. Upper left, top, lower right, keep it in the center, whatever. This one almost never gets used. Then there's scaling the bits, which is scale to fill is the default, where it just scrunches the bits, okay, to fit in the new space. It doesn't even respect the aspect ratio. But you could set the content mode to squish the bits, but keep the aspect ratio the same size so that a face doesn't go from, you know, an oval this way to a tall oval or whatever. But the one you guys probably are going to want most of the time is content mode redraw. And what that means is, when my bounds change, call my draw rect and let me draw myself again. Okay? And that's probably what you want, because your draw rect knows what your bounds are, and when it gets called, it can draw something appropriate for the bounds you're in. So like in your homework, for example, well, maybe your homework's not a great example, because probably the big views that are changing bounds, it's your subviews that you're going to want to lay out, which I'll talk about again. But if you did have a thing where you were drawing something in a view, like maybe we're doing our cards in concentration, and we always want them to be a certain aspect ratio or whatever, we could redraw in our draw rect or whatever. It's probably not a great example. In fact, let's go on to the next example, which is what happens if I have subviews and my bounds change? Because this is going to happen in your homework. You're going to have some view is going to have a subview, which is a lot of cards, your set cards. Because in assignment 3, now there's no limit on the number of cards that can appear on screen, right? In assignment 2, we limited it to like 24 cards as the most. Now, no limit, so you're always adding more cards. So you're going to have to put them as subviews of some view. You can't use stack view anymore, in other words. So what happens when your bounds change there? Well, when your bounds change, you're going to get sent this message, layout subviews. And that's an opportunity for you to go reset the frames by just changing the frame var on all of your subviews. Okay? So if you have subviews, you're almost always going to implement this method. And don't forget to call super to do it. Now, what's the one time when you're not going to implement this method? Is if you have subviews and you have auto layout on those subviews. Okay? If you have auto layout on your subviews, then the auto layout constraints will determine where the new frames are. Okay? So this would only be for views where you're not using auto layout. Okay? And that might be true of your assignment 3, whatever view contains your cards, probably not going to use auto layout. It would be almost impossible to write constraints that would work for laying out an arbitrary number of cards in arbitrary bounds. Okay? You're probably going to want to do that in code. Okay? So when your bounds change, you've got 2 different things to think about. If you have any subviews, layout subviews or auto layout. And if you draw something, then you've got to think about your content mode and whether you want to be asked to redraw. Okay, so that's it for the slides today. I'm going to go into demo here. The demo I'm going to do is a playing card. Okay, so this is going to be a new app, and it's just going to draw a playing card. You know, Jack of clubs, 6 of hearts, whatever. It's going to draw that card. We're going to draw that custom by ourselves. And today, all I'm going to do in the demo is the model of that MVC that draws a playing card, which is just going to be a playing card and a deck of playing cards. And the reason I'm going to do that is I want to show you enum. You haven't got a chance to see me demo enum, so we're going to use enums in our implementation of our model. On Wednesday, I'll continue with the drawing part of this demo, where I'm going to draw this playing card, and then I'll do some slides on multi-touch, and then we'll add some multi-touch to the playing card, swiping to go to the next card, we'll do tapping to flip the card over, that kind of stuff. Okay, your assignment 2, of course, is due on Wednesday, as you know. Assignment 3 will be assigned on Wednesday. It's just to make your set game custom cards, okay, drawn with a custom view. That's what assignment 3 is basically about. We don't have a Friday section again this week, unfortunately, due to some scheduling conflicts, but next Friday we will, and it will be on source code management, okay? Okay, let's go create a new app here. Okay, so I'm just going to go over here, use this same splash screen, but I'm going to say create a new Xcode project, because this has nothing to do with concentration here. As always, we use a single view app. I'm going to call this app playing card, because that's what it does, it just shows a playing card. We're not doing any database, we're not doing testing yet. We're going to put it in the same place I put concentration. We're not doing source code control yet, although, like I say, next Friday we'll learn about that. Here's my project. Now this time I'm going to keep my XC assets, right? Here's my XC assets where my app icon is here. And I'm going to keep that because I'm going to use some images for the face cards, so you can see how to draw images there. But I'm not going to use my launch screen or my app delegate here, so I'm just going to put them again in supporting files. I just like to get them out of the way so they don't really kind of demand my attention. Now, before I even go here and build my UI for my playing card thing, we're going to go do our model first. So we're not even going to do any UI to start. We're going to do model first. So how do we create model files? Remember, File, New File. And we pick this one right here, Swift File, which is a non-UI, right, a UI-independent thing. And when we do that, we ask for the name. So let's first start by doing a playing card. Okay, now my model is just going to be a deck of playing cards. So these are going to be UI-independent representations of playing cards, a deck of that. So we'll start with the playing card itself, and then we'll do the deck. So here it is right here, import foundation. I'm just going to have it be a struct. There's really no reason for it to be a reference type. And it's going to be a playing card. Now, a playing card is made of what? Well, it's got a suit, okay, which I'm going to have some type for that, and it's got a rank. Right? That's all there is in a playing card, suit and rank. So how are we going to represent suit and rank? Well, of course, because I want to show you enum, I'm going to do it with an enum. Okay? So let's create an enum for the suit, and then we're also going to create another enum for the rank. Now let's talk about how we would do this. Now, suit is probably the world's simplest enum, right? It's the case, it could be spades, or it's hearts, or it's diamonds, or it's clubs. Okay? That's it. This is probably enough right here. Okay? That's really all we need to do for an enum. I am going to take this opportunity, though, to teach you a little bit about enum that I didn't mention even in the slides, but it was in your homework reading, so hopefully you got this, which is raw values. Okay? What are raw values in an enum? Well, it turns out that you can associate a fixed, constant raw value for every one of your cases. Okay? Now, Swift will even do some of this automatically. For example, if I make my raw value type, which I specify by just saying :type after enum, if I make it be an int, then it'll automatically make this one's raw value be 0, and it's going to make this one's raw value be 1, etc. Okay? 1, 2, 3, 4, 5. So it just goes in order, the lexical order that appears in the file. You can also make your raw value be a string, for example. And if I do that, Swift will automatically make this one be spades, this one will be hearts, this one will be diamonds. In other words, it makes the raw value be a string version of the case. Now, why would you ever want raw values? Well, to be honest, I think a lot of the raw value support backwards compatibility because in Objective-C, enums were essentially ints, right? 0, 1, 2, 3, 4, 5. So raw value, it's like a raw value int. But you could imagine it might be interesting if there is some piece of data that it makes sense to associate with all the cases. And again, it has to be fixed and constant and unique, okay, for all the cases. But still, you could imagine that. For example, I kind of thought that maybe this, suit raw, this might be a good one. If I made the raw value be string, maybe having the Unicode character that represents the suit kind of be associated with every case might be valuable. Now, how can you use raw value? Two ways. One, you can create a suit by providing the raw value, okay? And it looks just like an initializer on suit, open parentheses raw value. That's how you do it. And you give it like a heart symbol there, and it will give it back. Now, that's a failable initializer because you might give it a string like X that's not one of these 4 strings. Okay? And you can go the other way as well. You can, if you have a suit like suit.spades, you can say what is the raw value, and you can get this string. So that might be useful too. We don't really care about that in this demo, but I just wanted to show you about this raw value business. All right, let's go down to rank. Now, honestly, if I were doing rank, it would look like this. Case ace, case 2, case 3, all the way up case jack, case queen, case king. This is what all the ones in between. That's what I would do. Okay, but I'm not going to do it this way because I want to show you associated data. Okay, this is mostly for demo purposes. I would probably just do it as these 13 things. That would probably be the best representation for a rank. But instead, I'm going to do it with associated data, and so I'm going to have case ace. Then I'm also going to have case face, which means a face card, and it's going to have associated value, which is a string, which is either J, Q, or K. Okay? So this is going to be a face card. It's either Jack, Queen, or King. Terrible representation. At the very least, this should be another enum, not a string, which can be anything. It's kind of silly, but anyway. And then I'm also going to have case numeric, okay, for 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to have, of course, associated data int. Now, I could put in here like pips count. A pip, by the way, is one of these. A pip on a card is just one of these things. So a numeric card has 2 pips on it. 2 has 2 pips, 3 has 3 pips, etc. So I could put pips count here as documentation, but you know what? You actually don't want to do that if it's completely obvious what this would be. And if I had a numeric rank, it's completely obvious that this is the number. So I do not need that. Now, it's not very obvious what this is, but I already told you this is a bad representation anyway. But I just want to show you what it looks like to get the associated data out of here and use it, etc. For example, rank is an enum. It can have funcs. I could have funcs and vars on here. So I'm going to have a var called order, which is an int that's just going to return which position the rank is in the order. So I'm going to switch on myself, and if I am an ace, I'm going to return 1, because that's card number 1, right? If I am a numeric, then I'm going to get my number of pips, okay? And I'm going to return the number of pips. Okay, because if I'm a numeric card, then however many pips I have, that's my number. Okay? And then for face, I'm going to say case face, and I'm going to, get the kind, okay, Q or J or K. Now I've got the kind, I guess I could say, I'm going to go to the next line and say, if the kind equals J, then return 11, and then I guess I could go else if the kind, okay, but this is getting terrible, okay? This is going to be ugly, awful code. But turns out there's a lot better way to do all this, which is to go here and say, if it's face, where I get the kind, where kind equals J, then return 11. Okay, so this stuff with switch is actually a pattern matching language, which you can go in documentation and learn about. But one of the things it's able to do is where, okay, where it can kind of narrow this down a little bit. So now I can do that for all 3 here, the Q and the King, and return, well, you can see why I use this terrible string representation, so I can show you where. Now, notice when I do this, I still get this complaint, switch must be exhaustive. And it's like, what? Look, I do ace, I do numeric, I do face. How come it's not exhaustive? Well, because where makes it so these are not counting every possible combination of where. Okay, it could be, the kind could be something else. So of course I have to add here default break. Or actually I got to return something, so I'll return 0. This is also bad design. This probably wants to return nil, and this wants to be an optional. Okay, that would be better design. I'm not going to do it that way, but just so you know, that's bad. I could also have static vars here. Maybe I have a static var which is all the ranks, which returns an array of every single possible rank. And I'm going to have to kind of build that up because I have this weird data structure here. So I'll create something called all ranks, which could be a type array of ranks. And let's start it out with an ace. Notice here, by the way, that I have to type this side here. It can't really deduce this. If I took this away, right here, let's get these other warnings off here, return all ranks. If I took this typing right here, this static typing away, I'm going to get an error that it can't infer this type. And that's because there might be another enum that has a case of .ace. So how does it know which array of enums this is? That's why saying type expression is ambiguous without more context. So I can add more context by putting that type. I could also say rank.ace. That would add more context. And now it knows it's an array of ranks. Okay? So now let's also do for pips in 2.10. Remember, ... without the less than means including the 10. And now I can say all ranks.append a rank.numeric with that pips. Okay, so now I've added all my numeric ones. And then maybe for the face card ones, I'll just say all ranks plus equals an array that has rank.face, where the kind is a J. And then I'll just copy and paste, paste, comma, paste, and we'll do the Q and the king. By the way, if I do this, I only really need to put this rank dot on the first one, and it can infer the rest of them. Okay? Dots, though, need the dots. Okay, so I don't need rank dot, because it figured out pretty quick this is an array of ranks. These are all ranks, so it works. Okay? I could do the same all thing up here, by the way, too. I could have a static var all. I make it static because I'm getting all of them here. I'm not talking about a specific one, so I want them all. So this would be, we'll do the same thing here, a rank of suit.spades, .hearts, .diamonds, and .clubs. Oops, hello, .clubs. Okay, so this is kind of nice to have this static var, which gives me all the suits, all the ranks. That's going to make it a lot easier, actually, to create our playing card deck. So let's do that. Okay, so we've got this nice representation, not so nice, but somewhat nice representation of a playing card. Let's go ahead and make a deck. So I'm going to make a new file, okay, a new thing here. It's going to be a playing card deck. Here it is. Struct also, no reason for it not to be. Playing card deck. And what do I want in a playing card deck? Well, of course, I'm going to need a var, which is the cards in the deck, right? So I'm just going to make that be an array of playing card. I probably want this to be private set, okay, where I control the cards because it's going to start out being a full deck. And then I probably want some function like draw, which grabs a playing card out of there. So that's how you take a playing card out of the deck. So how would I implement drawing the card out of there? Well, I'm just going to say, let's see, I remember, I think I used something from concentration to do this. Check, I did. Oh, yeah, I did. Okay, so here I'm just going to see if I have any cards. Then I'm going to return cards.remove at however many cards I have, .arc4random. Okay, so I need to go over to concentration. Okay, here's concentration. Down at the bottom here, we have arc4random. So I'm just going to grab that out of here, put that in here, so I can use arc4random there. If I don't have any cards left, then I'm going to return nil. So I better make this draw return an optional playing card. Okay, so that way people can't add more cards to my deck. I just start out with a full deck. Okay, I got to start out with a full deck, so I better have an init that does that. Init is really easy to write given our nice playing card structure. Oh, sorry, this warning here. Cannot use mutating member on immutable thing. Everybody knows why that is. This is a struct. It's a value type. This mutates it by removing a card. So we have to say that this is a mutating func. Okay, another good example of doing that. All right, so here I'm just going to go through all my suits. For suit in suit.all and for rank in rank.all. Okay, then now all these alls that we did. But of course, look where I put suit. If you look at playing card over here, I put suit inside playing cards. See, I declared it inside. So Swift allows you to nest types, put types in other sides, which makes perfect sense here because suit only makes sense in the context of a playing card. So this makes perfect sense. But it does change the name of the suit. It's no longer called suit. It's called playing card.suit. Playing card.suit. And this is playing card.rank. Okay. Playing card.rank. Okay? So nesting just changes the names of things and the accessibility. If you do private and stuff like that, you might not be able to see it. So now that I have that, I can just have my cards append a playing card. Now, playing card, since it's a struct, is going to get this automatic initializer. You see it right there? So I'll double click on this to get that. And the suit is just going to be the suit that I'm for inning, and the rank is the rank I'm for inning. So now you can also see the nice context here and the nice syntax of for in when this is an array. Okay? These are arrays. We're just going through each element of the array, right? Remember, these are arrays right here. See, this is an array of suits. This is an array that we made, ranks. All right, so that's it. Now, last thing I'm going to do here is just print out some cards in my deck to make sure it's working. Kind of a cool place to put testing code is back in your view controller. Okay, if you look at your view controller, you got these two free methods. I'm going to get rid of that one, but I'm going to keep this one, which was mentioned in your homework. This is, view.did load is a great place to like initialize your view controller, and also just put like debugging code, checking things out, things like that. So here I could do, for example, let's just print out 10 random cards. So I'm going to say for underbar, because I don't really care about the indexed, in 1.10, because I want 10 cards. I'm just going to let card equal a playing card deck. So I need a playing card deck, var deck equals a playing card deck. Okay, so I'm just going to let the card equal deck dot draw. Now, this is going to be an optional playing card right here, right? Optional playing card because the deck might be empty. So let's go ahead and say if let, although I probably could put exclamation point because I'm only grabbing 10 cards. I know there's 52 cards in the deck, but we'll do if. And now I'm just going to print this card out. And I can print a card by using this little backslash parentheses. Swift knows how to print out things that have, we'll see what it tries to print out when we do this here. So let's try that and see what happens. So I have no UI, so this is going to be a blank UI, but it is going to print this stuff out on my console. So I really only need to just look at my console here. All right, so there's my thing here. So here it is, printing it out. Okay, and it prints out 10 random cards. Kind of ugly looking right here. Okay, it prints out all the vars and et cetera. One thing that's really cool that I don't have time to show, unfortunately, because we've already gone over, but I'll just mention it, is that you can make it so that something prints out really nice when it's got that parentheses, backslash parentheses, by making it implement the custom string convertible protocol. So if we made playing card implement custom string protocol, the only thing that's in that, if we do fix it, we'll see what it is this var description. And you can return, like here I could return, for example, a combination of the rank and the suit. And then I could go make custom string convertible for rank and suit down here, comma, custom string convertible. Okay, implement the description in there as well. Okay, which I don't have time to do. So we would go here, we would put description, we would go here, we would put the description, and we would implement these two vars, and then when we print out, okay, it would print this nice string with two nice strings for that. Then we wouldn't get all that really verbose printing out. So custom string convertible is a nice protocol to implement if you want things to print nice in the console. Okay, so that's it. I will see you on Wednesday. We will dive into doing the V and C part, which is to draw a playing card. And we'll learn all about custom views and all that. And then we'll do some multi-touch after that. Okay, see you then.
For more, please visit us at stanford.edu.